Hello, hi. There is an latest update from Neuralink. That moments after the brain implantation of their device, Neuralinks device, which will provide or is providing visibility into real-time neural activity. And here they released a video. In this video, you can see that video shows the gradual increase in activity as one of their recent participants wakes up post-procedure after the Neuralink brain implantation. Here in this video, you can see the brain activity where the thickness of the white stripes get increased. That is the brain activity that is being recorded by brain waves recorded by in the monitor. And I will also add up after this video of the recent past video that which we explained in the channel. I will also add up there. We explain detailedly on how the brain implant works and what are the procedures and what the AI agent which they implemented and how it's going to decode the neural activity. Okay, have a nice day now. Thank you. What the fish is this? Okay, getting into the details. Here you can see the video of neurons firing off in the brain. Neuron firing. Here billions of neurons sending rapid electrical signals across trillions of connections in the brain. Each time a neuron fires, it creates a burst of energy that travels along its axon, reaching neighboring neurons through tiny gaps called synapses. And these neural networks in brain aren't static. They constantly shift, adapting with every thought, memory and experience, which is a process called neuroplasticity. These neurons even synchronize their firing of electrical signals in a rhythmic pattern, which is known as brain waves. These are essential for different mental states like focus and relaxation. So here you can see the deep learning stimulation of brain activity, or those brain waves being decoded by the deep learning stimulation of a Neuralink company. Neuralink, using their brain stimulator, they've trained a reinforcement learning agent, which is also, we can call it as AI agent, to maximize bits per second, such that the maximum number of bits, more number of bits could be decoded in a second through the brain waves that which they are getting. So here is the oral policy converting brain data to cursor control in stimulation. And coming to the oral policy is a strategy that which reinforcement learning agent or AI agent uses to interact with its environment. The agent interacts with the environment and observes the state of the world. First, the agent, which is the reinforcement agent, learning agent, interacts with the environment from the electrodes that which it is getting the signals from the Neuralink chip and observes the state of world. This agent, neural network, artificial intelligence agent, uses its oral policy to decide which action to take. Then the agent receives a reward signal from the environment, which indicates how good or bad this current state is. So it rewards its inner system to improve its oral policy. So oral policy is a strategy that this AI agent uses to interact with its environment. And just like self-driving cars, BCIs are control systems, and BCI stand for brain computer interface, which is a technology that allows people to control devices using their brain signals. And Neuralink's brain computer interface chip is coin-sized and fully implantable. It contains thin threads with electrodes that record the activity of neurons. Such we call it as we have discussed, those are brain waves. The chip processes the signals and sends them to a digital device via Bluetooth. So high-fidelity stimulations of motor cortex activity can speed up evaluation of neural decoders and enable optimization methods like reinforcement learning. Motor cortex is the region of the cerebral cortex which is in the brain, involved in the planning, control and execution of voluntary movements in the brain. So high-fidelity stimulations of motor cortex activity can speed up evaluation of neural decoders that which the neural network Neuralink have and enable optimization methods like reinforcement learning. So high performance in stimulation is exciting, but Neuralink have a question to you. What happens when Neuralink deploys this neural decoding policy which this is shown now in the real world? If their stimulation is accurate, users should achieve similar performance in real world applications, wherein in the early stages of generative brain modeling, the monkey name called Pager which they use for this testing can already use decoders trained in simulation to acquire targets in real world. And Nuland, the first person who got the Neuralink chip implanted, holds the world record of 9.5 bits per second, highest bits per second world record. So what do you think? Can this approach scale to 10 bits per second and beyond for their further art spans of Neuralink? What are your thoughts? Thank you.